All right, so today we're going to go through the math part of selective high school placement test for March 2022. All right, so let's get started with question 1. 3 packages are weighed together. Their total mass is shown on the scale. Package 1 has a mass of 850 grams. Package 2 has a mass of 225 grams. What is the mass of package 3? All right, so the first thing we should do here is first figure out how much all 3 packages weigh together. So we look at this, the arrow is pointing right over here, which is in the middle of 2 kilograms and 3 kilograms. So we go to the middle of 2 and 3, that should be 2.5 kilograms. Or we can write that, if we put it in grams, as 2,500 grams. All right, so we can write this as equal to 1 plus 2 plus package 3 as well. Now, in the question, it does tell us the weight of package 1 and package 2, so we can minus both of them from 2,500 grams. So let's add up package 1 and 2 real quick. So 850 grams, which is package 1, plus 225 grams, which is packet 2, is equal to, so we add this up, so we get 5, 7, 10. So 1,075 grams. So now we can minus that from 2,500 grams, which would give us 1,425 grams, which is now package 3, which is your answer. So we go down to the answer options. That would be answer option C. Okay. So that is how you do question 1. So move down. Question 2. At a garden shop, Claire is packing plants into boxes. Each box holds 6 plants. She has 149 plants. She wants to fill 27 boxes. How many more plants does she need? All right, so the key part of this question here is actually more plants. So when the question asks us that, that means we actually don't have enough plants at the moment. So if we know each box holds 6 plants and we want to fill 27 boxes, let's first find out how many plants do we need in total. So let's do 27 boxes times 6 plants. That gives us 6 times 7 is 42. So 2, 4, 6 times 2 is 12 plus 4 gets 16. So that gives us 162 plants. Now, we only have 149 plants. So let's find out how many more we need. So let's do 162 minus 149, and that gives you 13, which is answer option D. Okay. So don't forget, anytime you need to pause, you can pause and write down any of the working out. All right, let's go to question 3. All right, so let's take a look at question 3. The diagram below follows these rules. Multiply the number in the square by 4. Multiply the number in the triangle by 3. Find the difference between these 2 results and write it in the circle. The number in the square is greater than 1. What is the number in the square? All right, so there are actually 2 approaches to this question, which you can do. So the first is just guess and check. So you can try each answer option. And so, for example, if we try 5, right, we'll multiply the number in the square by 4. So we'll do 5 times 4, which gives us 20. And multiply the number in the triangle by 3. So the triangle's number is 2. So we'll do 2 times 3, which gives us 6. And if we minus these 2 numbers, we get 14, which is the number in the circle. So your answer would be 5. Now, if you wanted to do this without guess and check, and instead you want to do the algebraic method, this is how you would do it. So first we would let the square be x. So just any random number, we'll just say x, okay? So we know 4x, because we have to multiply the number in the square by 4. So we get 4x minus 3 times the triangle. So we can write 3 times the triangle, which is 2, is equal to 14. So we get 4x minus 6 is equal to 14, which gives us 4x is equal to 20. So x is equal to 5. So that would be the algebraic method of solving this question. Okay, both methods are fine. Just do whichever method you feel more comfortable with. Okay, all right. So let's move on to question 4. All right. Rana, Penny, and Joshua share a pizza. Rana eats 2/10 of the pizza. Penny eats 4/10 of the pizza, and Joshua eats 2/5 of the pizza. Which of the following statements are correct? Okay, so the first thing we'll actually do in this question is we'll actually change Joshua's fraction to be out of 10 as well, just so they're all the same denominator. So instead of 2 over 5, we'll convert that to 4 over 10. So we have Penny is 4 out of 10, Joshua is 4 out of 10, and Brana is 2 out of 10. Okay, and if you add them all up, that does equal 10 out of 10. So let's see, which of these statements are correct? They eat the whole pizza. That is correct, because we add 4 plus 4 plus 2, we get 10 out of 10, which is the whole pizza. So that is correct. Joshua eats the pizza. So we know that's not true because Rana only eats 2/10 of the pizza. So statement number 3, Penny eats twice as much pizza as Joshua. So we know that is not true as well because Joshua and Penny both eat 4 out of 10. So we can do a cross there as well. So the answer for this question, which of these statements are correct, would just be A, statement 1 only. Right, so let's move on to the next question. Question 5. Which of the following calculations show how to work out the number of seconds in 24 days? Well, if we take a look at this, right? So in 24 days, right? So first of all, we do 24 days times the amount of hours in each day, which is 24 hours. So we'll do 24. So we'll write days times 24 hours. And in each hour, there are 60 minutes. So we'll times it by 60 minutes. And in each minute, there's 60 seconds. So we'll times 60 seconds. And this is answer option B. Okay. All right. Let's move on to question 6 now. There are a total of 160 children in 6 classes in a school. The column graph shows the number of children in classes 1 to 5. The column for class 6 has not been drawn. There are 30 children in class 3, and then we have the graph below. Now they're asking us how many children are in class 6. Okay, so when we look at this graph, we don't actually see on the left we don't see any numbers. So we can't actually tell how much each of these columns actually are. But what the question does tell us is that there's 30 children in class 3. So I'm just going to count up really quickly and find out how many of these increments are there for class 3. So let's do 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so we can see that class 3, if we draw a line across, is at 15 increments. So we could say 15, I'll just say I for increments, is going to equal the 30 children, right? Because again, we're doing class 3. So we know that 1 increment is going to be equal to 2. So where do we go from there? So it does actually say at the start of the question that there's 160 children. So if we add up class 1, 2, 3, 4, and 5, the remaining amount should be class 6. So let's go ahead and do that. So, okay, so we know class 1, so I'll just write 1 is equal to, we draw a line across, it's at 10 increments. And since we know 1 increment is equal to 10, is equal to 2, that will be 20 students. Okay, class 2, I'll just write them quickly. So we get 10, this is 14, 15, this is 13, this is 12. All right, so let's double them. So 2, instead of 14, it will be 28. 3, we know it was 30. 4 would be 26. And 5 would be 24 students. So we add all of this up. We add 20, 28, 30, 26, and 24. We get 128 students. And since we know there's a total of 160 students, the remaining amount should be class 6. So if we minus 128 from 160, we get 32, which is answer option C. C. Okay. All right. So let's move on to question 7. The total mass of the objects on the left side of the balancing scales is the same as the total mass of the objects on the right. Every triangle has equal mass. Every square has equal mass. Okay. If the mass of the triangle is 6 grams, what is the mass of the square? All right. So let's quick write down these two. So we have 3 squares plus 1 triangle. And because they're both the same, the left and right should be equal. We can put an equal sign and say it's equal to 4 triangles plus 1 square. So what we can do now is we can kind of write how many grams is equal to the triangles. So 3 squares plus 6 grams is equal to, so we have 4 triangles here, and 4 times 6 grams per triangle is 24 grams plus a square. Okay, so I'm going to take away this square, and I'm going to cross out a square on the left side as well, right? Because taking a square from both sides. So we'll get 2 squares plus 6 grams is equal to 24 grams. All right, and now what I'm going to do is I'm going to minus 6 grams from both sides. So we get 2 squares is equal to 18 grams, in which case 1 square would equal 9 grams, which is answer option D. Now, if you want, you could have actually removed some of the parts in the first equation. So we can actually cross out this triangle. We can cross out a triangle from here as well. And we can cross this square out as well. So we'll get 2 squares is equal to 3 triangles, in which case 2 squares would equal 18. And so 1 square is equal to 9. All right, so both methods work, whichever one you feel more comfortable doing. Question 8. So question 8 asks us, so the table shows the exact time taken by 5 racing drivers to complete 1 lap of a motor racing circuit. So we have a table here, and then it asks us, who are the fastest 3 drivers in order, starting with the fastest? So as you can see, they're all 58 seconds. So the next step for us is to look at the smallest first digit number. So in which case we get atoms, because we have a 0 here. Okay, so that would be the smallest number. So we know it cannot be C, it can't be B, it can't be A, because we have atoms first. Okay, next, if we can look at the answer options, Smith is second in both of them. So we can say Smith is going to be second. And so the third is between Evans and Bartra. So all we have to do is figure out which one came first. And if we look here, 2 is before 3, which means Bartra would be faster than Evans. So this would be 3, which means our answer is E, Adams, Smith, and Bartra. Let's move on to question 9. A boy is standing at point P facing east. He turns clockwise to face a house, which is at point H. What is the angle of his turn? So the first step in this question is to actually draw which direction the boy is facing at the start. So it says east, and since we know north is facing upwards, we can say he's facing east, which is in this direction. So the angle that we're trying to find is this angle I'm going to be drawing in red. We know he's turning clockwise. So this should be the angle we're trying to find. Now they do give us a hint. They do say that this over here is 60 degrees. So one method you can do this question with is you can draw south, you can draw west. Okay, and since we know that in a revolution, there's 360 degrees, and since there's 4 kind of directions, between each direction would be 90 degrees or a right angle. So from east to south, that's 90 degrees. From south to west, that'll be another 90 degrees. So now all we have to figure out is what is this tiny little part here? And since again, we know west to north is 90 degrees, and we already see that there's a 60 degrees here. If we minus 60 degrees from 90, we're left with 30 degrees, which would be this little part over here. So now we know from east to the house, it would be 90 degrees, this one here, plus the next 90 degrees, plus the 30 degrees up here. Okay, which gives us 180 plus 30, which is 210 degrees. Okay, now the other method for doing this question would be to go the other way. So since we know he is facing east, what we can do is we can find out this entire part and just minus 60 and this 90 degrees here. So we can do 360 degrees minus 90, which gives us 270 degrees. So we're just minusing this section here. And then all we have to do is minus that last 60 degrees from here, which also gives us 210 degrees. Okay, so both methods would work. I would recommend the first method. All right, let's move on to question 10. Alex had $76. He spent some of it in a shop. Then he gave half of what he had left to Charlie. Charlie spent a quarter of what Alex gave him on lunch. Charlie spent $9 on lunch. So the question asks us, how much did Alex spend in the shop? All right. Now, to do these questions, I would recommend a sort of tree diagram just to kind of have everything clearly written. So I'll show you what that means. So we'll start off with $76. Okay. And then from that, he spent some of it. So I'm just going to put a box and a little question mark. We don't really know how much he spent in the shop. Then from that remaining amount, again, we don't know how much that is. So I'm just going to put a little box. He gave half of what he had left to Charlie. So we can write half. Now, if he gave half of what he left to Charlie, he would also have a half. Okay. Now, from the half he gave to Charlie, Charlie then spent a quarter of it on lunch. So we can just write a quarter for one of the halves. And yeah, we'll write quarter. So other than the quarter, he would have 3/4 left. Now then says Charlie spent $9 on lunch. So this little quarter here would actually be equal to, I'll do it in red pen. So this little quarter here will be equal to $9. So now what we're going to do is we're going to slowly work backwards. So if the quarter was equal to $9, right, that means the full amount would have been 9 times 4, which is $36, right? And since now we know that this $36 is half of what he gave to Charlie, the full amount that he had before he gave any money to Charlie would be 36 times 2, which is $72. And since $72 plus this little mystery amount is equal to 76, that leaves the mystery amount being 76 minus 72, which is $4. Now, I would recommend, if you do have trouble with these questions, I would recommend doing it this method, drawing a little diagram just so you know what happened. If you are a bit more confident, you can do this just in your head and just write down just these numbers here. Okay. Let's move on to question 11. A rectangular prism is made from identical small cubes. Each small cube is solid and looks like this from the side. The 3 diagrams below show 3 different faces of the rectangular prism. How many small cubes is a rectangular prism made from? So the first step in this question is to figure out which one of these faces belongs to like front, top, side. So we can say, if we say this is front, if we say this is the top, And let's say this is the side. All right. So now that we kind of know which faces these belong to, there are two steps. So if you are feeling pretty confident, you can see that from the front, we have a face of 1, 2, 3, 3 times 5. So this would be 15 cubes. Okay, so just 3 times 5 across will give us 15 cubes. And we look at the side and the top, we can kind of see that there's only 2 layers. So we have 1 layer here and another layer here. That's kind of also shown in the side part. You see 1 layer and 1 layer. So we know there's 15 cubes into 2 layers, which means it's 15 times 2, which is 30. Now, if you are not feeling that confident and instead you want to draw a diagram, I'll quickly draw kind of what that diagram would look like. Okay, kind of like what your diagram would look like. So as you can see, we have 3 stacks on top of each other, and we have 2 full layers, 1 here and another one behind it. Okay, so we just be 15 times 2, which gives us 30. Question 12. Jennifer sells bunches of flowers. She wants to make a picture graph to show the data in the table. So we have the days and the number of bunches of flowers sold. So on Monday, she sold 24, Tuesday is 28, Wednesday is 36. She wants to use these pictures only in her picture graph. So we have a whole flower and a half flower. She will not draw any other fractions of a flower. Which of these keys can she use to represent the data correctly? So in key X, we have a full flower is 4 bunches. In key Y, a full flower represents 8 bunches. Okay, so which of these keys can she use to represent the data correctly? So the first thing we actually take a look at in this question are the 3 different keys. So we have 4 bunches, 8 bunches, or 12 bunches. So what I'm going to do is I'm also going to write, this is the whole flower. I'm going to also write what the half flower is equivalent to as well. So 2, this will be 4, and this will be 6. Okay, so the question is pretty much asking us, which one of these keys can we use by itself to actually get these 3 totals up here? Okay, so let's start with key X. Key X represents 4 bunches, so that 1 flower is 4 bunches. So can we make all 3 of these numbers using 4 bunches or half a flower, which would be 2 bunches, which is correct. We can do 24, which is 6 times 4. We can do 28, which is 7 times 4. And we can also do 36, which is 9 times 4. So all 3 are able to be done using key X. So key X, I'll give it a red tick, which means it is possible to use key X. Now key Y represents 8 bunches, and half a bunch is 4. Now again, we can also use key Y to get all 3 numbers. So Monday, 24, this is just 8 times 3. 28, this is just 8 times 3 plus 4. And 36 is just 8 times 4 plus 4. Okay, in this case, don't forget, these 4s here are just the half bunch. Okay, so key Y can also be done. Now let's try key Z, which is 12 bunches. Can we make 24? Yes, we can, right? So 24 is just 12 times 2. What about 28? So 12 times 2 is 24, but we can't get an extra 4 bunches because 6 bunches is half a flower. So we're actually unable to make 28 bunches just using 12 or 6. So unfortunately, key Z cannot be used. Okay, so our answer is B, just key X or key Y. Okay. All right, so let's move on to question 13. Question 13. 3 different numbers are chosen from the numbers 3, 5, 6, 8. They are then added together. Which of these statements is/are correct? So we got the total can be a multiple of 8. The total can be a multiple of 3. The number is always odd. All right. So since we're adding these numbers together, there are actually only 4 combinations for the numbers we can use. So we have 3, 5, 6, which gives us 14 when we add them together. There are 5, 6, 8, which gives you 19 when added together. We have 3, 5, 8, which gives you 16 when added together. And 3, 6, and 8, which gives you 17. And there are different orders of the numbers, but since we are adding them all together, they would give us only these 4 numbers or these 4 results. Okay, so now let's go look at the answers. The total cannot be a multiple of 8. Well, we know that's not true because one of our options is 16, which is a multiple of 8. The total can be a multiple of 3. So that's also false because none of these numbers on the right are multiples of 3. The total is always odd. Again, we know that is false because 16 and 14 are both even numbers. So our answer is A. None of these statements are correct. Okay, let's move on to question 14. The diagram shows a triangle inside of a rectangle. The area shaded gray is 84 centimeters squared. What is the area of the triangle? Well, to do this question, we have to first figure out what is the area of the actual rectangle. Because if we were to write this equation out, we will get area of rectangle minus the shaded, so the gray area, would actually give us this leftover area, which is the white triangle. So let's quickly work this out. So area of rectangle. So if we look at the numbers they give us 11 and 12. So as you know, the area of a rectangle is the length times the width. It would just be 11 times 12, which gives you 132 centimeters squared. And since we know the shaded area is 84, let's chuck into our equations. We get 132 minus 84 gives us 48 centimeters squared, which is the area of the triangle, and answer option D. All right, let's move on to question 15. All right, question 15. Sojong has been recording rainfall for the last 5 weeks by collecting it in a container. The container was empty at the start of week 1. Sojong recorded the amount of rain in the container at the end of each week. No water was lost during the 5 weeks. The diagrams show what he recorded. So we have end of week 1, 2, 3, 4, and 5. During which 2 weeks was there exactly the same amount of rainfall? All right. So the thing we have to remember for this question is that the water is cumulative, which means if we look at week 2 and it has 100 milliliters, does not mean in week 2 we actually got 100 milliliters. We actually have to look at the difference between each week to find out how much was added. So let's quickly go through what that would mean. So over here, we have 60 milliliters. So as you can see, so this is 100 milliliters and there's 5 intervals, 1, 2, 3, 4, 5. So we have 100 divided by 5, that gives you 20 milliliter intervals. So as I said before, this would be 60 milliliters. So because we don't have anything before week 1 and the container was empty at the start of week 1, we know in week 1, there was 60 milliliters of rainfall. Now for week 2, we already had a 60 milliliter in the container when we started week 2. So all we have to do is find out what is this new increase, which is this amount here, which is 40 milliliters. Okay. And again, for week 3, we want to find from 100 milliliters all the way up to what this increment here. This increment is 1, 2, 3, 4. It's 4 above, so this will be an increase of 80 milliliters. So again, still, there's no numbers that are still the same, so let's keep going. Now, at the end of week 4, if we look back at week 3, we ended at 180, so just over here. So we're to find out how much it increased by. It will be 2 intervals, so 1, 2, which is a 40 milliliter increase. Now, we can actually stop there because the question says, during which 2 weeks was there exactly the same amount of rainfall? And if you look at week 2 and week 4, they both have 40 milliliters, which would be answer option D, week 2 and week 4. Now, again, if you didn't want to do the method I did, you can just find out how much each of these intervals, you could find out how much is in the container at the end of each week, and then just minus the previous week. So for example, it would be 60, 100, 180, 220, and then you could just minus going backwards. Okay, that way works as well. Let's move on to question 16. Brody is thinking of a quadrilateral. The quadrilateral has no parallel sides, 2 sides of 5 centimeters and 2 sides of 8 centimeters, and exactly 1 right angle. How many lines of symmetry does Brody's quadrilateral have? So our first step is actually to think about what quadrilaterals this could be. So I'm going to quickly write down all the different types of quadrilaterals. So we have a rectangle, we have a square, we have a parallelogram, we have a rhombus, we have a trapezoid, and we also have a kite. Okay, now if we look at these, the first statement says no parallel sides. And there's actually only one quadrilateral that has no parallel sides. So it's not a rectangle because they are opposite sides of parallel. Can't be a square because opposite sides are parallel. Parallelogram has parallel in its name, so it also has parallel sides. A rhombus, opposite sides are parallel, and a trapezoid, the top and bottom are parallel. So the only one we have left is actually a kite. And you might be wondering, how do you have 90 degrees in a kite? So you can actually have this top part be 90 degrees and just increase the length of the bottom sides to match that. Okay, so we'll have 8, 8, and then 5, 5. Diagrams not to scale. Okay, so how many lines of symmetry does Brody's quadrilateral have? It only has 1, because a kite only has the vertical symmetry. Okay, it only has this symmetry. So your answer is B1. All right, let's go to question 17. A gardener has a box of bulbs to plant in a garden. The garden has 3 sections. She plants half of the bulbs in the first section. She plants 3/4 of the remaining bulbs in the second section. She has 6 bulbs left, which she plants in the third section. How many bulbs are in the box at the start? Well, we actually are going to use a similar method to one of the previous questions we did, which is kind of like a mini tree diagram. So let's begin with the start. So we have a certain amount of bulbs, which we're going to have in a square. Now, from this square, it says she plants half of the bulbs in the first section. So we can put half over here, which will be the first section. Now, if she gives half away, she's going to have half left. So that's how much we have left. Now, from this remaining part on the right, it says she plants 3/4 of the remaining bulbs in the second section. Now, if we plant 3/4 of something, what are we going to have left? We're going to have a quarter left. So we're going to have 1/4 over here. And it says she has 6 bulbs left. So this little quarter that we have left should be equivalent to that 6 bulbs. So now let's start working backwards. So if a quarter is equal to 6, then the total amount before that split with the 3/4 and quarter should be 6 times 4, which is 24. So now we know that the half that she had after she gave half to the first section is 24. And again, if we work backwards, if half is equal to 24, the full amount should be 24 times 2, which is 48, which is your answer option E. Okay, now again, I would recommend using this method as it is very clear and it lowers the chance of any mistakes. Okay, question 18. A cube has been painted around one vertex as shown. Which of the following diagrams could be a net for this cube? All right. So the first part I'm actually going to check for all of these 3 diagrams is opposites. So if 2 sides are opposite, you can't actually see them in the same image. So for example, here we have 1, 2, and 3. The sides opposite to these 3, we're not going to be able to see. So let's check with diagram 1. So in a normal net, I'm going to label A. This side will be opposite this side. So they're both labeled A. This middle part would be opposite the bottom part, and these 2 will be opposite. So far, diagram 1 checks out. The sides with the triangles are not opposite each other. So diagram 1, we can pass for now. We still have to come back and check it. Diagram 2. Now, this is an unusual net, but we can still see the opposites. So here, this first part here, I'm going to label as A, is actually opposite this one over here. B is this opposite B, and C will be opposite C. Now, unfortunately for diagram 2, we do close this net. These 2 sides are actually opposites, which means diagram 2 is incorrect because these triangle parts cannot be opposite each other. Okay, and if we look at diagram 3 really quickly, this over here would actually be opposite this part here. This would be opposite this, and this would be opposite this. Okay, so diagram 3 does check out. Now, if you are wondering how I actually got these opposites, so all I'm doing is folding them in my head. So if you do have troubles with these types of questions, make sure to practice. So for example, I'm going to write B at the top. So this is the B side. So A would be right next to it, and this side would be C. Now, since this, the second B is actually at the bottom of the C, which is this line here, means this B would actually be the bottom of the shape. Okay, and this A, since it's on the right, now if we look at it from the bottom, this would actually come to this side. Okay, which is again why it's opposite this original A. And similarly, this C would be on this side over here. Now, what's interesting is that this first A actually has the triangle on this side. And C, this last C, is actually on the opposite side. It's like the triangle is nowhere near this little triangle here, right? Which means diagram 3 is incorrect, okay? Because the triangles don't match up, all right? And if we look at diagram number 1, I'm going to draw something similar as well. So we're going to have B. Okay, now draw a line down. We'll have a triangle over here. Okay, now if we turn this cube a little bit over, I'm going to write this side is actually A. So we'll have this part covered here. Now C, which is this C here, would have this triangle part covered here. Okay, and coincidentally, D this B over here, sorry, would actually be coming in at the bottom and would form the part with it. Okay, so diagram 1 is the only one correct. And since we already proved diagram 2 is wrong and diagram 3 is wrong, and since none of the answers actually say all of them are wrong, we also can assume that diagram 1 is the only one that is correct. Okay, this was a pretty tough question, especially if you do struggle with visual reasoning. So I would recommend practicing these cubes and the net type questions, okay, because they are very common. All right, question 19. A bag contains 3 colors of disc, red, blue, and yellow. There are an equal number of red discs and blue discs. There are twice as many blue discs as yellow discs. One disc is selected without looking. What is the probability of selecting a blue disc? Okay, so if you look at, so if we know that red, so we can write red disc is equal to blue disc. Okay, and we know there's twice as many blue discs as yellow discs. So we could say blue would equal to 2 times yellow. Okay, so now I'm going to write everything in terms of yellow. So we can write yellow would just be equal to yellow. We will have blue is equal to 2 yellow. And since we know that red is equivalent to the same thing as blue, we can write red is also equal to 2 yellow. Okay, so what is the probability of selecting a blue disc? Well, we have kind of 5 yellows here. So we can say blue would be equivalent to 2 over 5. Okay, so 2 over the total, which is 1 plus 2 is 3, plus another 2 is 5. Okay, so the answer would be D. Question 20. Here is part of the menu from a cafe. The prices have been torn off. Okay, so we have a menu. A burger and a drink cost $6 in total. Chips and a drink cost $3.75 in total. A burger, chips, and a drink cost $8.50 in total. How much does a burger and chips cost in total? Okay, so the first thing I'm going to do in this question is I'm actually going to write these as an equation. So for the first one, I'm going to write a burger, so B for burger, plus a drink, so D, is equal to $6. Okay, next we know that a chip and a drink is equal to $3.75. Okay, and the last thing to tell us that all 3 added together, so burger plus chips plus drink is equal to $8.50. So we want to find out how much a burger and chip cost. There's actually a quite interesting method. So what we're going to do is if you look at this equation here, right? B plus C plus D is equal to $8.50. If you want to know how much a burger costs, well, if you look at the first 2 equations we have from earlier, you know a chip and drink costs $3.75. And if we minus the chip and drink from this third equation with all of them, well, we're only left with a burger. So let's quickly do that. So for a burger, we're going to do burger plus chip plus drink is equal to $8.50. And we're going to minus chip and drink, which is $3.75. And what we're going to be left with is burger is equal to, let's quickly do that. So $8.50 minus $3.75. So we get 10, so we 5, carry 1 over, we get 7, and we're left with 4. So we get $4.75. Okay. We get a burger is equal to $4.75. So now let's do the same thing, but for chips. So we get a chip, is equal to, so burger plus chip plus drink is equal to $8.50. So we're going to minus the burger and drink, which is $6. So we're going to be left with chips is equal to $2.50. Okay. So if we want to know how much a burger and chip is in total, what we're going to now do is we're going to actually add this burger. We're going to add these chips together. So we can do $4.75 plus $2.50, which gives us 5, we get 12, carry the 1. 1 plus 4 plus 2 is 7. So our answer is $7.25, which is answer option C. Okay, let's move on to question 21. All right, question 21. Jason's clock was working normally until 7:05 a.m. So that's shown on the clock below. At 7:05 a.m., he dropped the clock. For the rest of the day, the clock's hands turned twice as fast as normal. At 3:25 p.m. that day, what time did the clock show? So from this question, the first thing we have to realize is that this 3:25 is the normal time. That's the correct time. Now, the time that the clock shows should be double however long that time was up to. So let's first find out how much actual time passed from 7:05 a.m. to 3:25 p.m. So let's quickly work that out. So 7:05 a.m. to 3:25 p.m. So first thing I like to do when dealing with time is to get the minutes correct first. So what I'm going to do is I'm going to add 20 minutes. So now it's going to be 7:25 a.m. Okay. Now from 7 a.m. to 3 p.m., let's find out how much that is. So what I like to do is I first like to go to 12. So to 12:25 p.m., that's plus 5 hours. And then from 12 to 3 is another 3 hours. Okay, so from 7:05 to 3:25 is in total 8 hours and 20 minutes. Okay, so since we know that the clock's hands turn twice as fast as normal over that time period, we're going to actually double the normal time. So instead of writing 8 hours and 20 minutes, it actually went forward 16 hours and 40 minutes. Okay, so another 8 hours and 20 minutes. So there's two things we can do now. So one, we can go from 7:05 a.m. and add 16 hours and 40 minutes, or we can add another 8 hours and 20 minutes to 3:25 p.m. So let's first do it the first way. So 7:05 a.m. and we're going to add 16 hours and 40 minutes. So when you're adding time like this, I would recommend using 24-hour time. So if we were to do this, we would get 45 minutes here, and then 16 plus 7 gives us 23. Okay, so 23:45, and in 24-hour time, if we were to convert this back to 12-hour time, this would actually be 11:45 p.m. Okay, now this was kind of a quicker method than adding 8 hours and 20 minutes to 3:25, but again, both work. So now what we're gonna do is we're gonna look at which clock actually shows 11:45 p.m. So we can't see an A, B, C, or D. So we're actually gonna go down a bit, and our answer is answer option E. All right, so you can see the hour hand is between 11 and 12, and it is pointing at 9. The minute hand is pointing at 9, which is 45 minutes. Okay, so this is 11:45, which is your answer. All right, let's move on to question 22. Okay, I have an equal number of $1 and $2 coins. The total value of my coins is $54. $1 coins weigh 9 grams and $2 coins weigh 7 grams. what is the total weight of all my coins? Okay, so we have an equal number of $1 and $2 coins, right? So if we add the two coins together, so $1 plus $2, that's going to give us $3 in total. Okay, so it means if we divide the total value of the coins by $3, it should give us the equal amount of $1 and $2 coins. So let's try that out. So $54 divided by 3 gives you 18. Okay, that means we should have 18 $1 coins and 18 $2 coins. Okay, so again, let's just double check, make sure this works out. So we have $18. So 18 times $1 is $18, and 18 times $2 is $36. And if we add these two together, yes, it does equal $54. So that was correct. Okay. Now, of course, you can try use guess and check to solve that, but this was a tiny bit quicker. Okay. So now that we know there are 18 $1 coins and 18 $2 coins, let's find out how much they weigh together. So there are two ways of doing this. So first way, you can just do 18. So there's 18 $1 coins. We do 18 times the 9 grams for the $1 coins, plus the $2 coins are 7 grams. So 18 times 7. Okay. So we do 18 times 9. This is 72. So 2, 7, 9 times 1 is 9, plus 7 is 16. So it'll be 162. Plus 18 times 7. We get 6, bring the 5 over, add it together, we get 12. So plus 126. Should give us 288. Okay. The other way you could have done this as well is you could have done, since we know that there's equal number of $1 and $2 coins, we can actually add the amount, like the weight of one $1 coin and one $2 coin. We can say $1 plus $2 coins would actually equal 9 plus 7 grams, which is 16 grams. And instead of doing two calculations, we just have to do one, which would do 18 times 16, okay, which would give us the same, which is 288 grams, which is answer option B. Okay, so both methods do work. Again, whichever one you feel more comfortable doing. If you can times bigger numbers together, you can do 18 times 16. If you want to make sure you're doing it all correct, take it step by step, you can do individual ones as well. All right, question 23. Two statues are 8 kilometers and 23 meters apart. A map maker incorrectly labels the distance between the two statues on a map. The incorrect distance is 23 kilometers and 8 meters. What is the difference between the correct and incorrect distances? Now, when we're adding or minusing kilometers and meters together, I like to first convert everything to meters. So 8 kilometers and 23 meters would now be converted to 8,023 meters, because 1 kilometer is 1,000 meters. Now next, 23 kilometers and 8 meters would be converted to 23,008 meters. Okay, again, 1,000 meters in every kilometer. So now what we can do is we can actually minus these two together to find the difference between the incorrect and correct. So 23,008 minus 8,023. So we can minus the 8 and the 3 to give us 5. So now we have a 0 minus 2. So I'm actually going to bring a 1 over from this 3. So we'll make this 2. This will be 10 minus 1. So we get 9. Okay, and we'll bring the 1 over. So this is now 10. So 10 minus 2 is 8. 9 minus 0 is 9. So we can't do 2 minus 8. So again, I'm going to bring 1 over. This will now be 1. So we get 12 minus 8 is 4. And we're going to bring this 1 down. So we get 1. Okay, so our answer is 14,985. Now again, since we know 1 kilometer is 1,000 meters, we can actually write this as 14 kilometers, 985 meters, which is answer option B. Okay. Let's move on to question 24. All right. So Jetta draws a map of an island, showing areas where there are only hills, only bush, or both. These three areas cover the whole island. And we have a little picture down below. The total area of the island is 164 kilometers squared. The total area where there are hills is 102 kilometers squared. The total area where there is bush is 80 kilometers squared. What area of the island has both hills and bush? Okay, so if we want to do this question, the first thing, there's actually two ways we can do this. There's the algebraic way, and there's also just guess and check. So I'll do guess and check first, and then we'll do the algebra method. So with guess and check, we know the total area is 164 kilometers, okay? So I'm actually going to label the hills as A. I'm going to label the bush as C, and I'm going to label both of them together, so the hills and the bush, as B, okay? So we know that A, so the hills plus both of them plus the bush is actually equal to 164 kilometers squared, okay? And we know that the hills is 132, the bush is 80. But don't forget, when it says the area where there are hills, that also includes the middle section, which also has some hills in it. And again, when it says total area where there is bush is 80, that's also going to include the B section as well, or part of the B section, okay? So if you want to do guess and check, you can just kind of use the 48 in this equation. So we can do A plus B plus C, actually, sorry. A plus B, A plus 48 plus C is 164, okay? So we can write A plus C is 100, and we'll quickly minus that. 116 kilometers, okay? So we do 132, so the area with hills and the area with bush, okay? And we minus this 48, we should get 160. So we add these together, we get 100, we get 212, okay? And if we minus, because both of these have actually taken into account B, so we minus 48 times 2, which is 96. That also gives us 116, which means answer option C does work. Now, as you can kind of tell, this method was a bit longer and a bit more confusing. So I wouldn't actually recommend using guess and check for this. So if we actually do the algebraic method, okay, so we can actually write these as equations. So the whole area of the island is 164 kilometers squared. So we can say A, again, same labels, A plus B plus C is 164 kilometers squared. Okay, next what we can do is we can write these two other equations. So it says the total area where there are hills is 132 kilometers squared. So we can say A plus B, so area of A, which is hills, plus B, which also includes hills, is 132 kilometers. Next, we can say that the area where there is bush is 80 kilometers. So same, we can say area of the middle part with bush plus C, which has only bush, is equal to 80 kilometers squared. Okay, so these are your two equations, 1 and 2. So we actually add the two together, 1 plus 2. We get A plus B plus B plus C is equal to 132 plus 80, which is 212 kilometers. Okay, so we can write A plus 2B plus C is 212 kilometers. Now, something interesting about that is that we already know that A plus B plus C is 164 kilometers. So we minus 108, like this equation here. If we minus this equation from this equation, from the equation we have down here, what we're left with is we can write A plus B plus C is equal to 164. What we're left with is B is actually equal to, if you minus these two, you get 48 kilometers. So if we could do that, B minus is 1, 0. So 12 minus 4 is 8. Bring the 1 over. 10 minus 6 is 4. Okay, we get 0. So it'll be 48 kilometers. Okay, so that is actually how you get that 48 kilometers using algebra. All right, let's move on to question 25. A display has 3 lights that flash at different intervals. The red light flashes every 2 minutes. The green light flashes every 3 minutes. The blue light flashes every 5 minutes. The lights all flash together at 7 a.m. How many times between 7:01 a.m. and 9:59 a.m. the same morning do the green and blue lights flash together without the red light also flashing? So let's first find out, when do they all flash together? So when do the green, blue, and red flash together? So to do that, we need to find the lowest common multiple of 2, because it flashes every 2 minutes, of 3, because green flashes every 3, and blue, which flashes every 5 minutes. So the lowest common multiple of 2, 3, and 5 is actually 30. Right? So that means every 30 minutes, all 3 lights flash, which is what we don't want. Okay, so we find the lowest common multiple of just green and blue. That's 3 and 5. So the lowest common multiple of 3 and 5 is actually 15. Because that's interesting. So every 15 minutes, green and blue flash, and every 30 minutes, red also flashes with them. So let's quickly write that down. So for example, we can say at 7:15, green and blue flash, but at 7:30, right, green, blue, and red flash. But at 7:45, only green and blue flash. So if we notice a pattern, we could just add 30 minutes from from 7:15. We can add 30 minutes, and that's actually when only green and blue flash. Let's quickly do that. So the next time 30 minutes pass, it'll be 8:15. So add another 30 minutes, it'll be 8:45. Add another 30 minutes, it'll be 9:15. Add another 30 minutes, it'll be 9:45. Okay, so these will be green and blue flashes. All right, so we add up all of these amounts, we get 6. So eraser. So if we add these amounts, we'll get 1, 2, 3, 4, 5, and 6, which is A. Okay. Now don't forget, in between all of these, they all flash at the same time, which is why we're not including them. Okay, because we don't want the red light to also flash. All right, question 26. So 3 planks of wood all have the same length. They are placed next to each other as shown. So we have a little diagram there. What is the length of 1 plank of wood? Okay, so they give us the full length of all 3 kind of together, but some of them are overlapped. Okay, so 135 centimeters is this entire section here. Oh, sorry. Okay, now what are these numbers at the top? Well, if we take a look at them, those are actually the overlapped areas. So this 40 centimeters is how much is overlapping here. And this 5 centimeters is actually how much this overlaps here. Now, something interesting about this is if we add these overlapped areas to the total, that would actually be how much all 3, if they were side by side, would be. Okay. The reason for that is that the overlap area is just how much you're losing. Okay. So if the total area of these, or the total length of these 3, sorry, is 135 centimeters. Okay. And the overlap area is 40 centimeters plus 5 centimeters, which is 45 centimeters. Okay. We can instead say the length of the 3 woods would instead be 135 plus the overlap, which is 135 plus 45, which is 180 centimeters. Okay. And since 3 wood is equal to 180, we can say a wood is equal to 180 over 3, which is 60 centimeters. Okay, which is your answer, C. All right, question 27. Allison shaded 3 small squares in the grid below. She wants to shade extra squares to make a pattern with exactly 4 lines of symmetry. What is the smallest number of extra squares she needs to shade? Okay, so it says 4 lines of symmetry. So if we draw a mini square here, we draw a mini square here. 4 lines of symmetry means down the middle, across, and diagonally as well. Okay, so those will be your 4 lines of symmetry. So now let's go back to this original image and let's actually take each kind of line of symmetry one at a time. So let's first start off with this vertical symmetry. Okay, so we want to make this vertically symmetrical. We want the same amount of cubes to be on each side. That means we need to shade in this cube and these 2 cubes here. Okay, so now it's vertically symmetrical. So now let's do horizontal. If you just turn your page over, you would realize that you actually also need to shade in these 2 sides here. Okay, so I'll use different colors, it's a bit easier to see. Okay, so now that we have these 2 lines of symmetry, we're actually going to go ahead and do the diagonal lines of symmetry now. So just to make it a bit easier for you in the exam, you can turn your page so it does look like it's vertical. Okay, I'm just going to turn it on the side and let's draw the diagonal line of symmetry. Okay, and if we look at it, to make this symmetrical, we do actually need another 2 cubes. So we need this side to be shaded in. Sorry, 3 sides, 3 cubes. We also need this cube to be shaded in, and also this cube here. Sorry, 4 cubes. We'd also need this cube here as well. Okay, so if we draw, so this one will be symmetrical to this with this, and these 2. Okay, we've got 1 line of symmetry left. Got the other diagonal. So again, if you look at it, let's see if we need to change anything. Nope, that looks pretty symmetrical. Okay, so let's find out how many in total we have added. So we got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we needed 9 extra squares shaded in order to make it symmetrical in 4 different ways. Okay. Question 28. All right. So Mirinda sold drinks at the class barbecue. The drinks were orange or lemon. She sold 33 drinks altogether. Which of these statements cannot be correct? Okay, so we have 3 statements here. All right, statement number 1. She sold 10 more orange drinks than lemon drinks. Statement number 2, she sold twice as many orange drinks as lemon drinks. 3, she sold 5 more lemon drinks than orange drinks. Okay, so for this one, we just kind of think about, is this possible or not? So let's start with number 3. She sold 5 more lemon drinks than orange drinks. So what we're going to do is we're actually going to minus 5 from 33. So the reason why is because, let's say lemon drinks, so we can write lemon drinks is equal to 5 more than orange drinks, okay? So we're going to add L plus O, which gives us 33 drinks. We can instead say lemon is 5 plus O. Right, 5 plus O is equal to 33. So you can write 2O would equal 28. So O is equal to 14, which then makes lemon equal to 5 plus O, which is 19. Okay, so that actually does work, right? 19 and 14 is a possible combination which would mean that she sold 5 more lemon drinks than orange drinks. So 3 is correct. Statement 2, she sold twice as many orange drinks as lemon drinks. Let's also do that. So we can say orange drinks is equal to 2 lemon, or 2 times the amount of lemon drinks sold. Okay, so again, let's do the same thing. So lemon plus orange is 33. So we can say, instead of writing orange, we can write 2 lemon. So we can write lemon plus 2 lemon is equal to 33. 3 lemon is 33, which means 1 lemon is 11. And since orange is double the amount of lemons, orange would instead be 22, which works. Okay, so it does make sense. So we can have 22 and 11, which adds up to 33 and also fits the statement. Now let's look at statement 1. She sold 10 more orange drinks than lemon drinks. Let's do that. So orange is equal to lemon plus 10. Okay, so we can write lemon plus orange is 33. Lemon plus L plus 10 is 33. So you can write 2 lemon is equal to 23. Now we have a problem. Can we divide an odd number by 2 without any decimal? And unfortunately, we can't. I will have a decimal left over. So statement number 1 is not possible, okay? You can't sell 10 more orange drinks than lemon drinks without selling like half a cup, okay? So your answer is, so the question again says, which of these statements cannot be correct? So answer is statement 1 only, which is false, okay? Now, make sure you read the question very carefully and don't accidentally write which of these can be possible, and instead put statement E, 2, and 3, okay? So just remember, which of these cannot be correct would be answer option 1, okay? So statement 1. Okay, question 29. This shape is a trapezium with 2 right angles. Anna has a square piece of card with side length 24. What is the greatest number of these trapeziums that Anna can cut out from this card? Now, sometimes what you might do is you might find the area of this trapezium, and you'll find out the area of the square, and then you would kind of figure out how many of these areas can you have in the big square. Now, what I would actually recommend instead is, if we actually look at this diagram of the trapezium, it looks like half a rectangle. Because what you can do is you can kind of layer another trapezium on top, and we would have a rectangle. So this would be 2 centimeters. This would be 3 centimeters. Okay. And so this is just one trapezium. This is 2 trapeziums. So now we have this rectangle that looks like this, which is, so 6 plus 2, which is 8 centimeters, and 3 centimeters tall. Okay. So now let's look at this square piece of card with side length 24. Okay. So what you can actually do is, because it's 8 centimeters wide, and we know this is 24, 8 centimeters goes into 24 3 times. So we can actually have 3 of these rectangles like this. Okay. So 8, 8, and 8. Okay. And since this is, the side length is also 24, and we know the side length of the rectangle is 3, we can have 8 of these like this. 2, 3. Okay, so we can have 1, 2, 3, 4, 5, 6, 7, 8 of these rectangles tall. Okay, so in total, the amount of rectangles we would have is equal to 8 times 3, which is 24 rectangles. Now, again, don't be caught up in this very easily made mistake. Your answer is not going to be 24, because that's how many rectangles there are. Now, don't forget, in each rectangle, there are 2 trapeziums. So we have to times this by 2 to get 48 trapeziums, which is answer option D. Okay, so this method was a bit easier because you didn't have to work out any area or do any calculations like that. Okay. Question 30. Jamal makes a number sequence. He chooses the first number in the sequence. Then he follows these two rules. Subtract 100 to get the next number in the sequence. Add 10 to get the next number in the sequence. The sixth number in the sequence is 8,451. Okay, so just like a lot of the other questions that we have encountered, there are two methods to solve this question. One, you can do guess and check to solve the question. So you can try each answer option as the first number, try each pattern and see if you can get it. Or you can use algebra. Okay, let's first try guess and check. So let's try 8,171. So let's say we start with the subtract 100. So we subtract 100, we get 8,071. Now we're going to add 10. We get 8,081. So minus 100, add 10. So again, we're going to minus 100 now. So we get 7,981. Fourth number. We're going to add 10, which gives you 7,991. And unfortunately, we can already tell that the sixth number is definitely not going to be that. Okay, because we're already in the 7,000s. Okay, so we know it can't be A. Okay, and going in the same logic, it cannot be B as well. Okay, because we're going to end up below 8,000 for the sixth number. Okay, so answer C, D, or E. All right, and of course, once you get to it, you'll go to answer option E with guess and check. You'll get 8,731. Okay, you'll minus 100 to get 8,631. You'll add 10 to get 8,641 minus 100. You get 8,541. Add 10, 8,551. And then you're going to minus 100, which gives you 8,451, which is what your sixth number is. So your answer would be E. Okay, now this does take a long time, especially if you do start at the first number, at answer option A. You would have to go through every single one almost to get to E. Okay, so now what we're going to do is we're going to try the algebraic method. Okay, so I'm going to let my first number be X. This is first. Okay, next what I'm going to do is I'm going to minus 100. So the second number would be X minus 100. Now for the next number, I'm going to add 10. So if I add 10 to X minus 100, I'm going to be left with X minus 90 because I added 10. Okay. Next, we're going to minus 100. So it'll be X minus 190. And same thing, I'm going to add 10. So it's going to be X minus 180. And last number would be X. So we're going to minus 100. So it'll be X minus 280. So the sixth number, which is 8,451, is just the original number minus 280. So if we want to work backwards, we're going to do 8,451. Instead of minusing, we're going to add the 280 to it. So we can write X minus 280 is equal to 8,451. So X is equal to 8,451 plus 280. Okay, so go back to this. Let's add it. So we get 1, 3, 7, 8. So 8,731, which is answer option E. Okay, now this method is a bit quicker than using guess and check. It's a bit more reliable as well. Okay. Question 31. A robot is facing southeast. It makes 58 quarter turns clockwise and then 93 quarter turns anti-clockwise. In which direction is the robot now facing? Well, okay, so let's first start off. Let's draw southeast. So southeast is down this way. So north, south, east, and west. Okay, so we know which way the robot is facing. All right, so now it says, so again, the question said 58 quarter turns clockwise and 93 quarter turns anti-clockwise. Now, that is quite a lot of turns. Now, if you were to go and individually turn it, and I go All right, so we're going to go this way once, that's 90 degrees. We're going to go another way once and another way. That's going to take quite a long time. And time is one thing you don't really have in these exams. So a quicker method to do is that every time we turn every time we do a quarter turn clockwise, and every time we do an anti-turn or anti-clockwise turn, we're actually just canceling the two out. If I were to go 90 directions in this way, and then I were to go 90 degrees the other way, well, we're just back to where we started. So the first thing we're going to do is we're going to do 93 quarter turns anti-clockwise minus the 58 quarter turns clockwise. And that's going to give us 35 anti-turn or anti-clockwise turns, okay? So after we minus everything, we're left with 35 quarter turns anti-clockwise. Now, again, this is still quite a lot of time, okay? For you to go 35, going like this, 1, 2, 3, 4, it's going to take a lot of time as well. So the next little tip that we can do is that every 4 quarter turns is just 1 full turn. That's going to leave us ending in the same spot. So for example, we go, so 1, 2, 3, 4, but back to where we started, okay? So the next thing that we can do is we can divide it by 4. So 35 divided by 4 is equal to 8 remainder 3, okay? Because 8 times 4 is 32, and then we'll have 3 left over, okay? So we know it does 8 full turns, so it's going to end up facing southeast again. So what we're actually left with is remainder 3. So it means we're actually going to be doing 3 anti-turn or anti-clockwise turns. So let's go 1, 2, and now 3. So we're left facing this direction, which is southwest. Okay. All right, question 32. This shape is made from rectangles. So we have a diagram there. And it says, what is the perimeter of this shape? Okay. So to do this perimeter, what we're going to do is we're actually going to shift some of these sides. So for example, if we have these two lengths over here, 1 centimeter and 5 centimeters, this is just this area here. What we can actually do, we can kind of move these out. So instead of running like this, we can instead write 5 centimeters and 1 centimeter here. And technically, that's still the same perimeter. Okay, we're not adding any new perimeters. We just moved it out. Okay, so if we look at the diagram, we would instead be writing with dotted lines the new part. And don't forget, this is no longer, so this entire side is no longer 14. It's now 15 centimeters because we have to add this extra 1. Okay, I'm going to do the same thing at the bottom here. Okay, so we added a 1. And now for this part over here, we can't really move these 3 centimeters anywhere. So what we can do is we can move this part down so it fits over here. Okay, so now what we'll have is we'll have a full rectangle with side length 15 and 16. Okay, and we'll have these 3 centimeters inside. Now we still have to add these 3 centimeters as the perimeter because again, that is the original shape. So the perimeter would be 15 times 2 plus 16 times 2 plus 3 times 2. So that'd be 30 plus 32 plus 6, which is 62 plus 6, which is 68 centimeters. Okay, which is your answer option E. All right, let's move on to question 33. All right, question 33. Timothy writes down the number 24. He reverses the digits to make 42. He then works out that 42 is 18 more than his starting number 24. Nicole writes down a whole number between 10 and 99. She also reverses the digits of her number. She finds that this makes a number that is 72 more than a starting number. What is the last digit of Nicole's starting number? Okay, now for this question, so if we look at this example, right, they gave 24. If we switch it, it becomes 42. Okay, you minus 42 minus 24, we get 18. Okay, so straight away we know that if you're minusing this second number from this first number and you're getting 72, your second digit should be a lot larger than your first digit, right? So the last digit of Nicole's starting number should be a lot bigger than that first number, considering we have a difference of 7. Now to get a difference of 7, right, and from 0 to 9, the only ways we can do that is we can do 7 minus 0, we can do 8 minus 1, or we can do kind of 9 minus 2, or we can do 9 minus 2, or like 9 minus 1 with like another number. Okay, we'll get to this part later. Okay, so all we know is that the last digit has to be 7, 8, or 9. Okay, because we don't use 7, 8, or 9, you're not going to get a difference of 70 or more. Okay, now let's look at 7. Okay, so if we have the second digit being 7, right, this first digit, again, like we established earlier, has to be smaller than that last digit, obviously get a difference. So we can't have like 87. Okay, so let's do 67. So 67 minus 76, or 76 minus 67, only give us 9. Okay, which is nowhere near the 72 that we need. So we already can tell that the first digit has to be a lot smaller than the second digit. So let's try 1. Right, so if we switch it around, I'll use blue pen for this, we'll get 71. So let's do 71 minus 17. So we do this, we don't get anywhere near 72 because we need 72 to be the difference. So we can say straight away, it's not going to be 7. 7's not going to be a number. Okay, so we can cross out these. Okay, now that leaves us with only 9. Okay, so we know it can't be 2, we know it can't be 3, we know it can't be 5. Has to be one of these 3 numbers. And if we just tried 7 and it didn't work, well, there's only one answer option left, which is 9. Okay, now to fully solve this question, which I'll do as well, okay, we're going to try 8 and 9. So what we're going to try is we're going to try 18, and we're going to do 81. Okay, so let's do 81 minus 18. This gives us 63. We'll do 7, 11, yep, 63. Okay, now 63 again is not 72, it's a lot smaller than 72, which means we can't actually use 8, because if we do 28 and 82, well, it's just going to give us an even smaller number. Okay, so let's try 9. Let's try 91. Oh, sorry, 19. Okay, so let's do 91 minus 19. That actually does give you 72. So that would be your answer. 19 would be a number. And again, like we did earlier, the last digit of starting number would have been 9. Okay. Let's move on to question 34. All right. Harry has a large solid cube made from 64 small cubes. He removes some small cubes. He now sees this view when he looks at any of the 6 faces. How many small cubes are now in the object? Okay, now to see this view from any of the 6 faces, well, we'll kind of have to punch a hole through this cube. So what I mean by that is we'd need to take out these 4 cubes, okay, go all the way to the other side so you can see light through it, okay, because obviously you can see straight through, okay. So for example, that little section here would be, so there's 4 cubes across, so 4, 1, 2, 3, okay, it'll look something like that, okay. We'll be punching this out of the cube, but that only lets us view this kind of like a hole from only 2 sides, this front side and the back side. So we need to do the same thing for the other 2 sides as well. So let's do this part first. So we punched this cube out. We got 4 sides here, or 4 cubes here, right? Now we've already gotten rid of this middle section. So I'm going to add the 4 cubes on. We've got 4 cubes here. Okay, so there's 4 cubes here. Sorry, my drawing is not the best, but there's pretty much 4 cubes here from this side that we've taken out. Okay. Now we also need to take 4 cubes out from the other side over here. So we're taking out these 4 cubes as well. Okay. Now that only gives us again 2 or 4 sides we can see from. So this side, so this left side, the right side, the front and the back. Now from the top and bottom, we also have to see kind of this hole, right? So again, we also have to take out, I use this green pen, we also have to take out this side up here, these 4 cubes, and also the 4 cubes at the bottom. So we're going to add, so taking out, add these kind of cubes here. Okay, we got 4 cubes here and then 4 cubes at the bottom. So again, if you were to kind of write this all out nice and neatly, right, you would say that you need to take out the middle section first. So the middle section would be this like set of 8 cubes, right in the very, very center of this cube, this kind of middle part. It will look something like this. Okay, now after you remove these 8 cubes, you have to remove 4 cubes from every side, right? To reach this center part, when you remove this 4 cubes, this 4 cubes, this 4 cubes, 4 cubes from each side. And there's 6 sides in total. So we're going to be removing 4 sides from 6, we're going to be removing 4 cubes from 6 sides, which gives you 24 cubes removed. Okay, now so we got this 24 cubes removed and also the very middle 8 cubes. So we'll do 24 plus 8, which gives you 32 cubes that were removed. And don't forget again, these are the removed cubes. So if there's 32 cubes removed and it says there's 64 in total, we'll do 64 minus 32, which means there's 32 cubes left, which is answer option B. Okay. All right, now let's move on to the last question, question 35. All right, so it says, Aaron and Tom have a game where they each spin this spinner once, and whoever spins the higher number wins. So we got 1, 2, and 3, and they seem to be equal. They play this game 8 times. During the game, Aaron spins 2 1s, 3 2s, and 3 3s. Tom spins 2 1s, 5 2s, and 1 3. There are no draws. Okay, so I'm just going to write out very quickly the games that Aaron won. So he won 2 1s. So I'll start with the 3. So we got 3, 3, 3. So the 3 3s, the 3 2s, so 2, 2, 2, and the 2 1s, 1 and 1. Okay. Now the main part about this question was actually this last sentence. There are no draws. That means Tom can't spin a 1 the same time that Aaron spent a 1. He can't have done a 2 the same time that Aaron did a 2. Okay, so we do Tom's 1s, and we need to put these 5 2s somewhere, right? And since they can't have a draw, Tom's 2s can't go here, here, and here. Oh, sorry. Which means the only possible places you can put Tom's 2s are the 3s and these 1s down here. Okay, which leaves his 2 1s and that 1 3 when Aaron did a 2. So 1 1 and a 3. Okay, so now the only step we have left is to figure out who won each of these times. So Aaron won once, twice, 3 times, 4, and 5 times. Okay, because in the other 3 he lost. So Aaron got 2, got 3, which is a loss. Aaron got 1s and Tom got 2s. Okay, so Aaron won 5 times, which is answer option C. Okay, and that is the end of the math section.